Welcome to Matlab Simulink for Beginners Class 2. Today we are going to see about how to create a model, how to create an input signal and output signal, how to link and how to compile. So this is the today agenda. Let's go to the Matlab. After opening a Matlab, it will open a blank page like this. This is not a default path. The default path could be a different one. So here you can navigate to your folder where you want to create the model. Here um, I want to create a model inside the MATLAB training. So for doing this, you go to new option and here select Simulink model. And here there are several options. So here select a blank model. So we will start with the blank model. Yeah. So it will open a blank model without any inputs or submodels inside it. So here go to save and save the model first. So I want to save this as a remote control as a short form of HFC. Okay, after saving the model, now we want to replicate similar to our architecture. So here is our main block and here are the inputs and here are the outputs. So similar way, we will also create our model. Let's go back to the MATLAB and go to modeling. Here, click insert subsystem. So this will create a small diagram. So in this diagram, you can see you have a one input and one output, and the output is connected to the input. So you can double click, you can go inside, and you can see that this input is connected to the output. So go back to the previous parent model. For doing that, you can either press escape key or you can here you can click the parent. Next, change the subsystem name to HHC say 20 millisecond. So give a meaningful name. So by seeing the name, you can understand that this software component going to execute in a 20 millisecond. So by assigning this one, it will not automatically will execute in a 20 millisecond. So there are some other options so that we will discuss later. And then make a size bigger than the default one. So let's go back to our architecture. So in our architecture, we can see there are 7 signals. So let's create the input signals in MATLAB. So for doing this one, double click on the white space and here you can type either input or I1. So this will create an input port. So you can connect the input port like this and give a name similar to our architecture. So vehicle speed. So I want to copy this name. Okay. Then similarly, let's create other signals. I'll do copy paste. Okay, so the input signal should not have a space in between. But let's create the last. Okay, if you want to link this signal to this model, then click here and drag it to the model. Okay, similar way, you can connect all the signals the same way. So now we have created the input signals. So same way, we can create output signals. For doing this one, double click in the white space here and type out. So this will create output signal. So let's connect this default output to signal 1. Similarly, create signal 2. Yep. Copy the names. Okay. Connect similar way like the inputs. And make sure that your input signal name is reflected here as well. So otherwise, when you go into this model, your input signal doesn't have a name. So it's very difficult to identify what kind of signal is this. So it's better to give the same name. Okay. Now if you go inside the model, so now you can understand that this signal represents vehicle speed. So now this is the model, so which accepts these 7 inputs and it generates 2 output signals. Similar way, let's change the output signal name also here from out1 to the real signal name. Here, okay, let's do some formatting here. Either we can format like this, each signal in a proper order. But there are some automatic method like select all the signals and go to format and select this option, arrange automatically. Yeah, by doing this one, yeah, you can see Matlab automatically arrange this, so we don't need to do it manually. Let's see, next step, let's modify the model settings. Here we want to change the settings as per our embedded system requirement. So for example, so to come to the first one, the solver. So in the solver, we have to select this as a fixed step. The fixed step indicates that this task is executed at a fixed rate. In the embedded system, most of the embedded system, you know that each task executed at a particular time. So that's we call as a cycle time, either 5 milliseconds, 10, 20, like this. So if you want to execute our model in the same way, so here we have to select as a fixed step, and then in the solver, you have to change as a discrete. So these are the two options we have to change. And the third option is here. So here we have to input the task cycle. So whether you want to execute this model in a 5 millisecond or 10 millisecond. So here we have to input in terms of seconds. So for example, if you want to execute in 5 millisecond, then you can input as a 0.005. But for my model, so I want to execute in a 20 millisecond. So I put it as a 0.02 second. Okay, next we can leave other settings as it is. Next, go into the hardware implementation. Here I want to select as Infineon as my device vendor, and it's a tri-core CPU. So I will select tri-core here, and go to code generation. So here is the main thing. So which compiler, which is your uh, target? So that we have to select over here. So this will shows a lot of options, like whether you want to execute this one in a Visual C or in the embedded system. So I always select embedded coder. So this will generate the code according to my embedded system need. There are some other options like whether you want to generate this as the S function or the library function. So you can select according to your requirement. And the next one, what's our target language? Whether it is C language, C or C++. You can select your target language. So I will leave this as C. Yeah, these are the basic settings you have to change. Then click apply and then OK. Okay, now we have created our black box model, and we also changed the model settings. So at the bottom of the screen, you can see that the setting is changed to fix the step discrete. Now we have to inform our compiler that these input signals are not originated inside our module. That means these are external signals which is coming from other modules. So in order to do that, we have to create a data dictionary, Simulink data dictionary. So for that one, we go to link to data dictionary. So you can select this option. So far, we have not created any data dictionary. So we have to create a new data dictionary. So click new, and here we input our data dictionary name. So this data dictionary contains XML signals. So I rename it as fill hole control external. Okay. So now we have created a data dictionary. So when you go to your main page, so here you can see, so this is our model and this is our data dictionary. You can open our data dictionary. So here you can see, as of now, there is no signals or parameter inside this. If you want to add an input and output signals in a SLDD, then you can click this option. So this will create a signal. Let's change the name. We want to provide the same name which is provided in the software architecture. So third signal name is here. Fourth one as a break applied. And fifth one is a acceleration position. The last one is a disable, let's see, and we have two output signals. Okay, here um, we have to change the data type of each signal. For example, vehicle speed. This is a single, so that means it's a float signal. The vehicle speed represented in a float. Only here we can give the unit as a meter by second, and we can set the minimum value as 0 and maximum is 100 meter by second. And next, let's change the slope. Similar way as a single, minimum value is minus 50 to 50, and it is provided in terms of percentage. And the pressure target also a single, that means a float, 0 bar to 200 bar. And the next one, this is a boolean, which represents zeros and ones. And yeah, this is very interesting one. Here the gear signal is enumerated data. So create a data type first, and then we can assign the data type to the signal. Next, as a next step, want to create enumeration data type, then you select this option, Simulink enumerated type. So here we can assign the type definition name as a gear type, and then the enumeration values we can assign here as number P or N D. This is an example. Okay. Okay, now we have created a enumerated data type. Now we can assign this data type to the signal. So here we can see this uh, enumeration data type. So we can select this one. Okay, this is how we can create an enumeration data type. And then let's move on to the next one, engine torque signal. So this is also a float signal. So I select as a single, and the torque value minus 3000 to 3000 unit as a Newton meter. And this next signal is a disable silver control. So this is a Boolean, so which tells that this component is enabled or disabled. So the next signal is a brake applied signal. So this is also again a Boolean, so which tells the brake is applied or released. So here we make assumption that 0 means release, 1 means brake is applied. The next one is the acceleration position. Yeah, this is also a float, indicates the gas pedal position from 0 to 100%. Okay, now we have created all our external signals, but we have not yet mapped our external signals to our model. So in order to do that, we select this option, Model Data Editor, and here we have to select this option, Resolve, means these signals are coming from external components. So now we can see that there is a new symbol, and it's mapped the signal according to our selection. So the mapping of our input signal under the external signal is done. Actually, here we have to make one point that this linking is done automatically if the name is same. But in case if the name is different, then it will show an error. For example, if you have an input signal, say an example, and this is connected to your model. And when you go to your model data editor, and then you have selected this as a resolve as an external signal. Now this signal doesn't exist in SLDD, so you can see that there is a red mark, red symbol. So you can resolve this problem by clicking this button, and then you can create a new signal for this. It's not visible here. Yes, here you can select this option, create a new variable, and then here you have to select option where you want to create this external variable. So we select SLDD, the value is a Simulink signal. So here we have to do the same thing what we have done in SLTD. So same thing. So this as a Boolean 0 and 1. Yeah, now this red mark disappeared. So by this way, you can also do I hope you have understood about how to create an external signal and how to map it with your model. Let's save the model and yeah, we can use this option to compile your model to see whether there is any error in your model. But as of now, we have just linked only the input and output signals. We have not written any code, but still we can check. Yeah, if there is any error, then it will populate a window and indicate where the error is. So currently there is no error, so there is no error indication as well. That's our end of today's class. So in today's class, you have learned about how to create the model and how to create a data dictionary. So how to create an external signal and how to link the external signal to your model. And also we have learned about how to modify the settings, model settings according to your need. And also how to check the basic compilation. So that's all about today's class. And in tomorrow's class, we will see about how to create subsystems. That's the module inside our main software component. Okay, see you in the next class.